Okay, this question says the second term of a geometric series is, now is going to be our equals here, 9 times the fourth term. So we need to write that out as such. So u2 equals 9 lots of u4. Now the next thing we do is come and use our facts. Now these are given in the formula booklet, okay, it's on the second page there. u2 is going to be AR to the 2 minus 1, which is just AR, equals 9 times AR cubed. Now, from there, we're asked to go and find the possible values of the ratio. So what I want to do is just bring everything over to one side. AR minus 9AR cubed equals nothing. And then, what I want to do is factorise out by the biggest power. You take out both things here, so you get 1 minus 9r squared equals 0. So we've got two options here. Either, one second, either this AR equals 0, or this 1 minus 9r squared equals 0. So if we're trying to get r here and find possible values of r equals 0, or 1 equals 9r squared, so 1/9 is equal to r squared, so plus or minus the square root of 1/9 is equal to r, so the solutions are r equals minus a third, or r equals a third. Now in the next bit we're told that the given ratio is positive. Okay, so if it's positive then it must have been this one, because that's not positive. Where is it? That one's not positive, and that's 0, so that's not positive either. It's nothing, it's neither positive nor negative. And find the sum to infinity of the series. Oh, it says and the sum to infinity of the series is 12. Find the third term of the series. So try and make sure you answer the question, because I'm terrible at this bit. Don't actually answer what it said. We're using this, which again is given in the formula booklet. So I want to sub into that. So I'm going to get S infinity is equal to A over 1 minus R. I was told that was 12. That's A, because I don't know it. And then it's going to be 1 minus a third. So then that is 2/3. This bit by here is 2/3. It's divided by 2/3, so I'm going to bring that over here to be 2/3 times by 12 is equal to A. And then 2/3 of 12 is 8. So 8 equals A. Now I know A and I know R. I was actually asked in the question to go and find the third term of the series, which, like I said, I'm terrible usually at that, so make sure you're answering the question. So find the third term. So the third term would be U3 is equal to AR squared. So that would be 8 times by a third, and then that squared. So that would become 8/9. Okay, so in this question here, we're told that the second term of another geometric series is minus 4, and that the sum to infinity of the series is 9. Now that sort of tells us one bit here. We know that r must be mod of r, which means it just has to be either bigger than minus 1 or smaller than 1. It says then show that this common ratio has this equation. Okay, so the second term would be u2 is equal to minus 4. u2 is AR. And then we're also told S infinity is equal to 9. So that's A over 1 minus R is equal to 9. Okay, now there's a couple of different ways to solve these. The best way usually with geometrics is to try and do some sort of form of division here. I'm not sure I particularly fancy that, to be honest. I don't think it's going to work very well. So what we could do is we could try and do some sort of substitution method here, that we could find out that A is equal to minus 4 divided by R. That's one way of solving it. In fact, actually, that's the way I am going to solve it. So A is equal to minus 4 divided by R. So I'm going to call that 1, and I'm going to call this 2, and I'm going to sub 1 into 2. Sub 1 into 2. So where I've got A, I'm going to change that to minus 4 over R. All divided by 1 minus R equals 9. I'm now going to bring this denominator over here. So I'm going to get minus 4 over R is equal to 9 bracket 1 minus R. I'm then going to expand that bracket to get minus 4 over r equals 9 minus 9r. I'm now going to times every bit of this statement here by r to get rid of this denominator, which I don't like. So I'm going to get minus 4 equals 9r minus 9r squared. I'm now going to create a quadratic, which is going to have a positive r squared term, so I'm bringing all of this stuff over the equals over to here. So I'm going to get nothing left on that side, get a positive r squared there, so 9r squared minus 9r minus 4. So let's hope that that's what they had up by here. That's exactly what they had up here. Okay. It then says find the value of r, giving the reasons for your answer. Okay, so I've got a quadratic term there, so I need to factorise it. So I'll show you the way I like to factorise, but there's a couple of different ways too. I'm going to times 9 by minus 4 to get minus 36, so that's these two terms here, here and here, and then they must add to this term by here, minus 9. So the pair of numbers that do that would be minus 12 plus 3, and then I'm going to write 9r and 9r in the brackets there. Minus 12 is going in one, plus 3 is going in the other, but then if you use this method, you must cancel down the brackets. So that becomes 3r minus 4, and this would become 3r plus 1. So r is equal to 4 over 3, or r is equal to minus a third. Now, it says, find the value of r giving a reason for your answer. So it's one of these things here. And it's the point that I made up by here straight away when I read the question. Mod of r is less than 1. So this answer here can't exist because it's got a sum to infinity. It has to have this, as we have a sum, we have s infinity. You can't have a sum to infinity if your number's bigger than 1. Okay? Okay, so this question here says another geometric series has the first term a in common ratio r. The second term of the geometric series is 9, and the sum to infinity is 48. So this is pretty much the same question that I just did. So definitely have a pause of the video and try and beat me to this one, and I'll show you what the working is here. Okay, so here's the answer to what I had. So I said that the second term is 9, sum to infinity is 48. So I subbed into these formulas here to find my answers. AR equals 9, A over 1 minus R equals 48. And then did exactly the same trick as before, rearranged 1 and then subbed it into 2. And then I got that. This time it gave me like a much bigger sort of, not sum, equation here than what they actually asked me to do. I had this in the actual question that was given, and if you have a look at that there, it's still like the same number and a number, and I just divided through by 3 and it gave me exactly what I wanted. To then go and solve what it wanted, I factorised, and I did 16 times plus 3 to get 48. They must add to minus 16. Pair of numbers to do that, minus 4 and minus 12. Again, drop the r squared there to just an r, and then put in a minus 4 and a minus 12, cancel down, and found r was a quarter or r was 3/4. Because it's a sum to infinity, r can actually be either of those values, and it sort of gave you that hint in the question because it said find 2 possible values for r and the corresponding values for a. Now that's the one thing I haven't done, and that's the thing that the point I was making before, which is make sure you answer what the question says. So 2 possible values of r, tick, haven't done that, so I need to go and do that. I'm going to go and use this formula here because it's set up very easily for me to work out. So in 1 I would get a equals r divided by a quarter. That's something you can go into your calculator and it works out a is 36. Or I could have had 3/4. So a would equal 9 divided by 3/4. So that would be 12, I believe. Okay, so we're told this geometric series has first term a, well we know all this stuff, has first term a and common ratio r. The fourth term is a and the sum of the third, fourth and fifth term is 28. So let's generate a statement for that. So the first statement is going to be the fourth term is 8, so u4 is equal to 8. So u4 equals 8, and the second thing we're going to have is the sum of the third, the fourth and the fifth term is 28. We're now going to generate AR cubed equals 8, and we're going to have AR squared plus AR cubed plus AR to the 4 is equal to 28. Now my initial thought when I first looked at this question, I thought, oh, I can sub in 8 for that and then do some working around with that. But there's actually a better way to solve geometrics, and the best way to solve them is to do Division, because the geometric is going up in multipliers, the best way to cancel them out is through division. So we tend to get the biggest powers up on top, so we're going to do equation 2 divided by equation 1. So that's going to give me AR squared plus AR cubed plus AR to the 4 equals 28, and we're going to divide that by AR cubed equals 8. Now, the way that we're going to do this is we're going to factorise, but we need to factorise fully. That's what the main mistake was in the PPE. You weren't factorising fully here. So we take out the biggest factor, which is going to be AR squared, and that's going to be 1 plus R squared that's going there. And that is going to equal, well, 28 divided by 8, that cancels down to, what, 14 over 4, 7 over 2. And then this thing here. Now, we have got AR cubed on the bottom, haven't we? But we've got this AR squared here, and we want to cancel that out. So I'm going to take AR squared times by R. That gives me a lovely bit of cancelling here, where they both go. And I've got 1 plus R squared is equal to... In fact, actually, let's keep that in a bracket and bring this 2 by here. Let's bring that over, so it becomes times by 2. And then we're going to get 7, and we're going to bring this denominator here, this R, we'll bring that over and times by the 7. So now, what we're going to do is expand the brackets to get 2 plus 2R plus 2R squared equals 7R, and then we're going to rearrange into a quadratic to get 2R squared minus 5R plus 2 to get it in the form of a quadratic. Let's check what we had up here. Lovely stuff, that's what we're supposed to have. Given that the mod of R is less than 1, find the value of R and the corresponding value of A. Well, that's just your factorising now. I'm not going to go through that bit, okay? Okay, this question is nowhere near as hard as it seems. It's telling you that the pth term is equal to 16, okay? So P is equal to 16. P plus 1, that would be the next term. So P plus 1 is 24. So we can go and work out what the ratio is from that fact. So what have we times 16 by to get 24? Well, all you have to do for that is just do the term before it divided by the term behind it. So R would be equal to 24 over 16, so R is equal to, what's that, like 3 over 2? Or 1.5. Okay, whichever way you prefer to think about it. Now, from there, it says find the P plus 4th term. So P plus 2 would be the next term, P plus 3 would be the term after that, and P plus 4 would be the term after that. So all we need to do is 24 times by 1.5, so 36. 36 times by 1.5, which is 54. And then 54 times 1.5, which is not really worth doing it in your head in case you get it wrong, is 81. Okay, and that's literally all you had to do for 3 marks. This is a geometrics question taken from a more recent paper. So again, let's read and pick out the key bits here. So let me just make the highlights a bit smaller. The 10th term of an arithmetic series. And this is an arithmetic series, it shouldn't even be in here. Okay, so we'll skip that one. Okay, this one here I wanted to go through. Now this you'll be put off by the amount of marks here, okay? It says the 4th term of a geometric series is 2 and the 7th term is 54. So let's write that. So that would be sorry, let me change pen. It would be U3 is equal to 2 and then U7 is equal to 54. Write that as geometrics would be AR squared equals 2 and then AR to the 6 equals 54. And then the best way to solve geometrics is through division. So we'll divide those. So we're going to get 2 divided by 1 because we like to get the bigger power, this guy, above that one, so it'll cancel down a bit nicer. So AR6 over AR2 equals 54 divided by 2. So the A's are going to cancel. AR6, AR squared would become AR4, and that becomes 27. Okay. I've made a little mistake here. I've just noticed it. Because the way I spotted this, rather than me just deleting it and saying, oh, let's not worry, let me start again, is I know that 27 is a cube number. I know that it's not a 4th root. If you do the 4th root of 27, it'll be rank. So you see here the 4th term. I think I just started to solve it straight away. So that should be AR4. So that should be AR cubed. That should be AR cubed. So that should be R cubed. Okay? So then taking that over would give me R is equal to the cube root of 27. So R is equal to 3. So I found the common ratio of the series. Find the sum of the first 10 terms. Now, to do that, I need to go and use this formula here, So Sn is equal to A, 1 minus Rn, blah, blah, blah. Now, that means I need to know A. So I need to say, when R equals 3 in 1, we're going to get AR cubed, so A3 cubed equals 27. No, it's not. I'm sort of answering the question again. Let me rub that out. Oh, too much. My bad. There we go. There you go. AR cubed is equal to 2. So that means A is equal to 2 over 27, okay? Now you can get sort of ranked numbers like that. We're just going to leave it as a fraction. It's not the nicest thing in the world, but hopefully this is going to work out reasonably well. And you could go and work it out if you wanted to. You could go and chuck it in and do 2 over 27 times by 3 times by 3 times by 3, and it should give you 2. It should do that, okay? If it doesn't, then you've done something wrong. So Sn, now we want Sn, we want n to be the sum of the first 10 terms. So it's going to be S10 is equal to A, which we've just worked out is 2 over 27, and then 1 minus R to the n. R is 3, and then n is 10, and it's all over 1 minus R, so that's over 1 minus 3. And that's going to go into your calculator, and it will get you the following answer. So that gets me the answer 2,186. It's actually 0.7, okay, it's 0.96, blah, 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 so it's equal to 2187.0 to 1 decimal place. Now, it was this final bit here that was quite hard, part B. It says, find the least value of n for the nth term to exceed 125,000. Okay, so the way we're going to do that is we're going to say un to exceed is greater than 125,000 there. Now, un, we know, is equal to AR to the n minus 1, and that's greater than 125,000. Now, we know A, we know that's what is 2 over 27, times by R, which we know is 3, but then we don't know what n is, so that's going to be n1 there, is greater than 125,000. First thing I'm going to do is take over that 2 over 27 to get 3 to the power of n minus 1, and then 125,000 divided by 2 over 27 comes to quite a nice number, actually. I wasn't expecting that. 168,750. So put commas in there, it's like 1 million odd. Okay, so now we're going to take the 3 over, and the way I like to take the 3 over is I'm going to take it over as log base 3. And then of that number, so I'll just put that into my calculator as ans. Now bear in mind that's n minus 1 is greater than, so log base 3 of that answer comes to 13.05 blah blah blah. Okay, take the minus 1 over, it becomes plus 1, so we get n has got to be greater than 14.05 blah blah. So it says find the least value of n for that to exist or to exceed 125,000. Well, n has got to be greater than 14 a bit, so therefore the least number is n equals 15.